Alright, for this question, when I'm reading it, there are some key words that I consider. First of all, I spot that we mention area up at the top there. It talks about width and height and then also perimeter. So what I'm going to try and do is find something to do with area and something to do with perimeter. Well, let's do area first. I know that, and I don't have enough room to write underneath the in the spaces, so I'm going to write on the side here so I've got a bit more room. The first thing I know is that area equals x times y. Okay, that's the first thing I know. From the perimeter, I know that the perimeter, well, that must be x plus y plus x plus y. So the perimeter is 2x plus 2y, and it gives us in the question, it tells us that that equals 72. So I know that 2x plus 2y equals 72. Effectively now, I've got two equations, 1 and 2. What I'm looking for is something that's in terms of a and x. That's what I have to find. And I've got my equation 1 here my formula 1 here is in terms of a. My second one's got x's and y's. Well, I want to get rid of the y's. So what I'm going to do is I'm going to take formula 2. So from number 2, I get 2y equals 72 minus 2x. So divide everything through by 2, y is 36 minus x. I can then substitute that back into 1. So substitute that into 1, and I get a equals x times by y, and my y is 36 minus x. And if I just expand the brackets, I get a equals 36x minus x squared, which is exactly what we're looking for. So part B is relatively straightforward. I think we're looking for dA by dx. Well, I've got an equation for a in terms of x, so I just need to differentiate that. So moving on from here, so dA by dx is going to be 36 minus 2x. Okay, that was relatively straightforward. Part C then says find the maximum value of a. Well, let's consider what this curve looks like. If I consider a equals 36x minus x squared, that I know is quadratic, and it's going to be of this sort of shape. I know it's going to be of this shape because it's minus x squared. Because it's minus x squared, it's going this way round. So this is going to have a maximum point there, and at that maximum point, I know that the gradient of the tangent will equal 0, and the gradient of the tangent is given by dA by dx. Okay, and I know that that will equal 0 at the maximum point. So that gives me, if dA dx equals 0, well, I know from what I've just done that dA dx is 36 minus 2x, so that gives me 36 minus 2x equals 0, so 2x equals 36, or x equals 18. Therefore x equals 18. And now I need to find what the question, you go back to the question and check, the question says find the maximum value of a. Well, I found the value of x for which a is a maximum, so I now just need to substitute that into my original equation, a equals 36x minus x squared, and I've got therefore a equals 36 times 18 minus 18 squared, and that gives me, when I put it into a calculator, 324. I'll just